Hello together. Thank you for having me. Advanced engineering means looking into the future. And that's what I brought with me today, but I splitted my talk in two parts. In the first part, I want to take you on a short journey because I'm not a native of the automotive tribe. When I was young, I fell in love with data and databases, and against my father's advice, I went into business IT. And by some way, I found into the automotive world 7 years ago. And in the first part, I want to talk a little bit about this and my understanding on the software-defined vehicle. And in the second part, I want you to lean back and relax and take a little bit of look into the future together with me. And then at the end, I hope we can maybe discuss about this. Okay, so let's start with the slide. You have to know the past to understand the present. And when I came into the automotive industry from business world, one of the first things are, what are we doing here? Yeah, looking from top down, it looks somehow like this vehicle. And the first thing I learned is we are doing a cyber-physical system. Our software touches the physical world. Coming from business IT, software touches numbers and maybe things are also going wrong, but I was not used to killing people by my software. Yeah. So this is one of the big learnings I had here, cyber-physical system. I found out that all the OEMs used a pretty obvious strategy, divide and conquer, yeah, take the overall system, make it smaller, make handleable pieces, and then keep a top-level focus on integrating the whole system to provide the value. Focus on managing the interfaces between the parts, digital interfaces, mechanical interfaces, whatever, and manage your suppliers. So I started my way into the automotive world at Bosch. So I understand now the tier one view of the supplier and that it was always in the interest of the OEM to deliver on time, on budget, and in the best quality here. And what we also heard today, we created by Conway's law organizational setups. We mirror basically all the structure, and also our processes mirror this. Yeah? So that was my learning in the last 7 years. Okay, that's what happened the last 20, 30 years. And today we say, okay, this means the features are defined by hardware. In fact, there's a lot of software in the vehicle, but the way we do it, the way we distribute it, we build a distributed system, makes it very unflexible. It's not really that it is a pure hardware-based system. It is a software system, but not in that flexible way that we want to have it. So let's move on. Where do we want to go? We're heading in a direction that probably the EE architecture of the vehicle will look different. We want to have this flexibility in there. And one of the first understandings I had here is it's still a cyber-physical system. We still can kill people with it. We cannot just take off-the-shelf Linux and do some overnight coding and release that, and that will work. It's still a long, long way to go. And at the time when I joined there, 2015, we had discussions about this. Is this possible? There were really people saying, yeah, we want to do that. And we learned it will not be possible in that way. So we see there's a shift from this hardware to a software-focused working model. We see that there is now system and software level integration. And we see that there is something upcoming, what we call platform. And from the history in IT, we have seen this before, this story, when IBM developed the PC and Microsoft developed Windows on top of it. This became a very dominant platform where a lot of software business today relies on these two facts, that there's a standardized PC and there's a standardized operating system, and on top we can build software. And coming from that idea, it's obvious that everybody thinks, oh, that could be the right way to do also this for the car. And this is where I have big doubts that this does exactly match. But my point here is we will face the problem of being a platform developer and maintaining a platform from an OEM side. So what we can take out of the business IT world is pretty interesting things we see in the cloud development, DevOps, MLOps, for getting our software development done, getting our build chains done. We have heard this in previous presentations. These are the challenges we have to get these issues streamlined in a way that we can efficiently produce the software, but also now bring it to the car. And this brings us to the data-driven development, learn also from the things in the car. And that was the moment where I realized I have not done everything wrong in my life because data is returning to me. And here I can now really bring the two IT worlds together, the IT and the embedded world. So we look into the way that we have the development, we bring it into the car, we get the data out of the car via connectivity, via over-the-air updates, and we will look into a future where we have physical and digital development at the same time. We saw this in an earlier presentation that today's platforms are like version, nothing is compatible, but I'm pretty sure this will have to change in the long term to keep the maintenance of the software under control and keep the reuse of the software under control. So at this point, we would say features are now defined by software. What are the two key learnings I had in the last 7 years? There are two big communities. One I call the real-time community, real-time and safety community, and the other one is, I say, the IT and cloud community. And the future I see only in the convergence of these two communities. We have to work closely together. I saw in the last years that each community on its own, the one said it's not possible, the other said it's possible but in a too risky way. So we have to converge these two communities in the organizations. And the big question is how to do that. And that's my second big learning, that sometimes organizations out of itself are not able to do that. And this is where these activities like Eclipse SDV or Sophie, I like them very much because it gives us the possibility that we can meet on kind of a neutral ground and real-time people can work together with IT people and really develop prototypes and can take the knowledge and the experience back into their organizations and shape the organizations. So from my point of view, this will be a very important aspect in the next years to get these two worlds together. Why do I emphasize this? Because for the next step now, we need this as a precondition. So let's just see, this would be our perfect picture. We have the development, it moves over to the car, the data flows back, we can fix things, we go back to the car. Wonderful world. So, in the next step now of my presentation, we look beyond that. And I know that's now a hard thing, talking about the next set of problems while I have not solved the current problems yet. Yeah? But that's why I'm advanced engineering. Yeah? The other stuff is engineering. Yeah? It's not my business. So, let's start the second part with another side. So LNK, I love it. Best way to predict the future is to invent it. And yeah, probably it helps us also in the software-defined vehicle context to think about the next step. Because I strongly believe that we have to come from the business point of view. We have to understand what could be business cases that drives the reason why we should do the software-defined vehicle. Without any business case, I think there's no sense in it. Yeah? So what could be the future here? Close your eyes and imagine embedded and IST systems are fully converged. That means we can do everything. We can do safety software in the cloud or in the edge. We have reliable networks. The vehicle is part of something bigger. Yeah? So maybe it's better to use a real-world example. So let's take infrastructure-assisted driving. Who has heard of infrastructure-assisted driving? Okay? So the idea of infrastructure-assisted driving is pretty simple. We do not put the intelligence all into the car. We make the infrastructure intelligent and let the car use the infrastructure for doing things, and it's getting a complex, reliable, distributed system. So in today's view, we put everything into the car, and most presentations we have seen today were around this topic of we have to put functionality into the car and we have to develop this. So what we already see, we can do things together with the cloud. Simple things like map-based stuff. We upload where is congestions. We know about the movement of the car in the cloud. We do smart things, and we can go back to the car and say, don't take that route because it's blocked, use another route. So that's possible. But you see there are other functions, lane keeping, emergency stop, diagnosis. Let's think about moving this also out of the vehicle into what we call the cloud edge continuum. So we have edge computing power, like mobile antennas that provide computing power where you can run code on it. We have the cloud, we have the vehicle, and now we can shift functionality into the infrastructure, and it could move with the infrastructure. The infrastructure can assist the vehicle in doing things. Would open up interesting things. For instance, we don't have for everything a fully autonomous functionality. We can rely on the infrastructure. And maybe it's easier to see it in a way that we already have these kind of systems. Very early stage. Not as fancy as in the fabric that I showed here, but the Bosch automated valet parking is really a reliable distributed system because the vehicle hands over its control to the infrastructure. And the infrastructure is operating the vehicle to its parking spot and then handing the control back via the cloud to the owner. So this is the first glimpse of a reliable distributed system. And we will see in the next years, there's already a lot of research ongoing. Another example I can show you from IEEE Spectrum, they had a nice article about smart roads. That's what they're doing in Shanghai. They build roadside units with quite a lot of sensors, cameras, lidars, and they augment the view of the car. Every car that passes by via Vehicle 2X can access this information and gets a bigger local environment model than he could produce on its own. Because the car is limited about where's the camera height and so on, how far can I look. And together with this assistance, it would be possible to improve that much further. It's an interesting discussion, like what will be first? Will we see large-scale infrastructure-assisted driving or large-scale fully autonomous L4, L5 driving? That's probably an interesting discussion here. But that's exactly what we are looking into. And there's a lot of players in this field, and it's not only about this infrastructure-assisted driving. The really interesting use cases come up when you go over the boundaries of mobility, when you look at manufacturing or building technology. Give you some examples. If you do an automated valet parking with electromobiles, what do you get? The largest battery pack in the world that you can automatically control. Maybe we can do things with that. In manufacturing, logistics, there we don't need fully autonomous. We can work with infrastructure assisted a lot there. Yeah, we can improve this whole world of how goods are moved in a certain range. And I see in this topic of reliable distributed systems interesting use cases out of the vehicle-only world. There are much more players, but this also cries urgently for standardization. And to see what kind of USPs we really have in software in the vehicle and in what points we want to have standardization to enable bigger USPs. We heard about digitalization earlier, about services around the car, and I think this could be the next generation of services that we would be able to build, and where we probably would see also kind of different level of platforms, not only the vehicle platform, like parking platforms and so on and so on. So with this picture in mind, I would like to close. I hope it gives you a little bit of an inspiration, what could come, and probably helps us also to find a little bit more out what business cases would really drive us in the term of software-defined vehicle. Thanks for having me.